So I'm going to talk about mass reduction in heavy truck. And heavy truck, primarily in this case, the power end of the truck itself. Composites use in heavy truck is quite a good success story. Most of what you see when you see a heavy truck driving down the road is a composite material. Most all the body panels are composite or plastic. And there are also parts that you can't see that are structural members. Composites get used really only where they're cost effective, because nobody's going to use a material if it doesn't make sense. Why do composites make sense today for heavy truck? Well, primarily it's the low tooling cost, because trucks are an intermediate volume. They typically produce trucks in the range of 25 to 75,000 units per model. And the tooling to do that in plastic is much, much lower than the tooling to do that in other materials. So that's interesting that we've got a high level of composites use in heavy truck, but lightweighting and corrosion resistance really are not the primary reason for that. The primary reason is lower overall cost for the manufacturer. Many composites are used on trucks, though, to improve fuel economy for aerodynamics. Virtually everything that's red in this picture is either fiberglass reinforced plastic composite or some thermoplastic composites down here in the lower section. But the hood, which is done in one piece, is fiberglass reinforced plastic. This raised roof assembly, which is 12 feet long and stands about 6 feet above the normal top of the truck, is made out of just 4 pieces of plastic composite. In this particular truck, the door, outer panel that's painted, as well as the structural inner panels are composite. The firewall in this truck, which is not visible, and then these lower fuel tank covers are also composite. This is a composite door for that truck, and we're looking at the outer here of the door. The outer of the door is composite, and the inner reinforcement is also composite. The door affixes to the cab. The frame surround that the door fits into is a composite material. The roof is a composite material, and there are trim panels in the back here that are composite. Same thing, this happens to be a PACCAR vehicle. This is a Freightliner vehicle, and the same thing accrues here. Virtually everything you see here that's in blue is a composite material. When you look at all the opportunities inside the truck, from a mass standpoint, there's a lot of mass that's not visible in the engine and in the drivetrain and in the wheels that are candidates for conversion to plastic materials, and where they need to be structural to have high strength and stiffness to plastic composite materials. There's 2 opportunities that in heavy truck for reducing weights by using composite. The first is to take these composites, lower their density so that the existing composite parts can be lighter. And then we can also look at the applications that have not yet been converted to composites and get those into a lighter weight material. In order to lower the weight of the existing composite parts, they use low density additives. These are actually little micro balloons that can be incorporated into the plastic to help lower the density by about 25%. There's also the application of nanotechnology. Nanotechnology allows the resin itself to be made stronger and stiffer to work better with the glass fibers, and allows you to use less overall material for weight savings, but also a cost saving. And then there's alternate fibers. The predominant fiber that's used in these plastic composites is glass fiber, and glass is relatively heavy. It's a mineral, so it's got a density of about 2.6 or thereabouts. And other fibers are much lighter. Plastic fibers have a density less than half that. And then carbon fibers are not necessarily a lot less dense, but they are so much stiffer than the other fibers that they allow you to use less, or to make body panels that are thinner that have the same stiffness and performance. The other alternative is to convert more parts to composites. And there's a lot of excitement and activity here, which is the radiator support. There's also oil pans and a number of under-the-hood applications. This is what the frame rails look like in a heavier truck. And these frame rails are typically 3/8 inch to 1/2 inch steel forgings. There are several truck companies now that are looking at manufacturing these out of plastic composite materials for significant weight savings. So we've got these material characteristics for the composite material, which is that it's a very stiff material. It functions well in heavy trucks because trucks are large. They have large body panels. The body panels can't flex in the wind, so they need to be made stiff. The composite materials are also very corrosion resistant. You see heavy trucks on the road that are 10 and 12 and 15 years old, and you don't see rust on them. But really the driving factor has been the low tooling cost. That's why composites make sense mostly for heavy truck. Going forward, that's not going to change. Even though the heavy truck manufacturers are now significantly more interested in weight savings, they have to produce a vehicle that they can sell economically. The supply base for these plastic composites to the heavy truck OEMs is broadly based, and it comprises dozens and dozens of companies throughout the United States. Most of them small manufacturers, many of them with less than 100 people. They are providing a service to heavy truck that is really broad-based, and the feedstocks are all domestically sourced.